I can see how to get the points. Or 4.
So for all mine, my answers, I was getting like negative answers. Do you just make them positive or what? I don't know.
Yeah, I got a negative answer too.
So which one did you guys get negative answers on?
3.
3.
Yeah, let's do 3.
Number 1 was one of them. I don't know. I did for quite a few of them, but I didn't know what was going on.
Yeah, let's do number 3 and double check that one. But then sometimes you could potentially make it positive. Basically, Abby, if you're always supposed to do the top curve minus the bottom, and if you ever flip-flop them, then basically you did the bottom minus top, which means you're going to get the right answer, but negative. But if you did something else wrong, like a small math error, then that wouldn't be the case. But yeah, so number 3, I mean, it's pretty clear that this thing meets at 0, 0. Everybody good with that? Oh, this is a really horrible picture. I'm so sorry. Wow, that's bad. But anyway, it meets at 0, 0. And we know basically it's going to be from 0 to somewhere, and the parabola is on top. And then you're going to subtract out the line, which is on bottom. And so this won't be that bad to go backwards from, but we do need to figure out where they meet. So there's kind of like double the work to do for each problem, because you got to figure out where they meet, and you got to figure out how to go backwards. So to figure out where they meet, this is where these are the two equations. And I'm just going to set them equal to each other because that's technically substitution. Like this can just go in right there. So that's what I do a lot for these. If the y is by itself, is I just set them equal to each other.
Oh.
Yeah, so that can help you, like, because it's just a little bit easier than elimination.
Yeah. I don't know why I kept doing elimination, but
I think it's, I mean, I probably should have done one by substitution, because I think one of the ones that I did elimination in the notes, if I'm remembering right. Yeah.
Yeah, you did.
How would you guys solve this thing?
take out an x.
Take
Pull
out
out
a
a negative
2x.
2x.
Yeah, take out an x or take out a 2x, perfect. If you take out a 2x, you get 2x minus x. Oh, no, not 2x, just 2 minus x, my bad. And then you get 2x equals 0, which x equals 0, and that one we already knew about. It made it 0, 0. And then x equals 2, right? So this point is 2 comma something, and how we could figure that out is really easy. We don't even need it, but we could plug in a 2 to 3x and get 6, or you could plug in 2 to this grossness. So either one, you could plug 2 into and you get 6. But we actually don't need the 6. We just need the 0 and the 2, because those are the x bounds, right? Those are the x values. And so now we're at 0 to 2, and now we do our thing. So people who got negative answers, did you guys just flip-flop these on accident? Like, did you guys have 3x minus the other one?
Yep.
No,
Okay.
this one I actually got positive.
Okay, you got positive on this one, gotcha.
Yeah, I
So
only got the x equals 2 negative, but I kind of disregarded that because I was like, I know it's not negative 2, it has to be positive 2. And I see where I made that mistake.
Gotcha. So I would combine like terms here before I go backwards, but then going backwards here would be 2x squared minus 2/3 x cubed, I think. And then you plug in 2, which would be 8 minus 16/3. Which if you wanted to make a common denominator, then it'd be 24 minus 16/3, which is 8/3. So did you guys get 8/3 or 2 2/3?
I got negative 8/3, but, you know, I did the 3x minus the other one. That was the only one that I got right. And we
Well, we can do it. Did you guys want to do another one from the first page? Did you guys want to do number 4? Or?
No, I thought the rest of them were pretty.
Gotcha. Abby, did you
I know
want
that.
No, the next one I have is 5.
Oh, okay.
I just
you
got weird numbers for the other ones.
We could do another one really
Can we
quick.
just like check answers and then we can know if we need to go over it or not?
You know, that's a good question. I probably should have made an answer key. Because I actually don't have one in front of me. So here, let me, I'll just do 2 really, really quick, and then you guys can just make sure that it makes sense as we do it. So on this one, it'd be the integral from, and so I'm going to set x squared equal to 2x squared minus 25. subtract the x squared, so I get 0 equals x squared minus 25. So x equals plus or minus 5.
Mm-hmm.
So then those are my bounds, and then x squared's on top, minus this whole one, but you got to distribute the negative, so you get a plus 25 in there. And then negative 5 to 5 is negative x squared plus 25. Go backwards, negative 1/3 x cubed plus 25x. And then from 5 to negative 5, well, that's just annoying. So what is that? Negative 125 thirds plus 125. And actually, I'm going to make my life a little bit easier here. So that's going to be when you plug in 5. Subtract, when I plug in negative 5, I'm going to get positive 125 thirds and a negative 125. So when then I distribute that, I change the symbols, I'm going to get negative 250 thirds plus 250. But if I take this times 3 over 3, negative 250 over 3 plus 750 over 3, which is 500 thirds. Is that what you guys got?
Yeah.
Yeah. I think I did it backwards again, though, because I got negative.
Okay.
Yeah.
I found my mistake. I didn't
top
distribute in the negative.
Ah, there you go.
I don't know.
I mean, I will say, everybody, there's a chance for a ton of tiny, like, algebra mistakes on these, you know. Emma, I can probably, because this, I mean, you guys have probably realized this, it takes a long time for these videos to load, you know, after we record these. So whatever ones we don't do, I can I can put the answers up, like, when I post this.
I mean, I guess with most of these, you could just like nint it and get the answer.
True,
So
but you'd
I
also
could just do
like,
that. But
yeah, you'd also have to make sure that you like have, I mean, like if you're confident that you have the problem set up right, then ninting it is perfect double check. But some people, if they're just confused about having the problem set up right, then nint
that's
might
true.
not. Yeah. But yeah, I can do that. So that won't be too bad. Number 5, is that what you said, Abby?
Yeah.
So number 5, I think the hardest part for me is knowing which one's on top.
It's confusing.
I
Yeah.
thought it was the 2x squared plus 2x.
I think so. Yeah. And if we set those, if we set these equal to each other, 2x squared plus 2x equals x cubed plus x squared, I'm just going to move everything over here. So then you get 0 equals x cubed minus x squared minus 2x. And then you pull out an x. And then you can factor it. So x actually equals 0, which we know. X equals 2, and x equals negative 1. So that actually means that they would meet again on the left side. But I'm guessing we need from 0 to 2.
That's what I was like. I saw that x equals negative 1, but I was like, it doesn't show that, so I figured we didn't use that.
Right, since they just gave this shaded area. Nice. Sweet. So then the top one, I think we decided was x squared, 2x squared plus 2x. Subtract out the x cubed plus x squared. And then we're going to have to distribute that. And I'll combine like terms while we do. So we're going to have negative x cubed plus x squared plus 2x. And then we go backwards. Is that okay for everybody so far?
Mm-hmm.
Shoot, I did that wrong.
I love it when they give us 0 though, because plugging in 0 is just so nice. So plugging in 2, negative 8/4, which is negative 2, plus 8/3 plus 4. So that's 2 plus 2 2/3, which is 4 2/3. Or you could have 14/3. How you guys feel about that?
I did some math wrong because my decimal is 2.67.
Yeah, unless I did something wrong. Anybody?
I think
Um,
does that need to be x to the fourth?
Oh, dang, you're right.
Yeah.
oh yeah, yeah. Okay,
That'll
that's
do.
what I had.
Good, because then 16 divided by negative 4.
Negative four.
Aha! Now these will cancel. And we just get 2 2/3.
Okay.
Good save, Eli. Or 8/3. Beautiful. Nice,
Yeah,
yes.
it's 3.
Huh?
It's the same answer as 3.
Oh, yeah.
I know. I had thirds in like literally all my answers.
Yeah, there's a ton of thirds. Which one do you guys want to do next? Do you guys want to do, let's do either 6 or 7, but maybe both?
6 was probably slightly harder for me, but I'm good with whichever.
I'm good with 6.
Yeah, and 6 we can actually cut our work down a little bit, because do you guys see that those are symmetrical on either side? So what I'm going to do is, like on 6, you could find the integral from -4 to 0 of the cubic thing on top, right? And then subtract out this not line. And we would have to find from 0 to 4 of the line on top and then subtract out the cubic thing. But since these go through at -4, -28, and 428, that tells me that they're symmetrical. So that tells me let's just pick one and double it. Is that okay for everybody?
Mm-hmm.
Yeah.
Now that's work on number 9, because clearly number 9 is not symmetrical. It's like we're gonna have to do 2 different ones on that one. But let's just pick this one just because it's -7x. But we do have to distribute some things. I'm going to FOIL these 2 first because I see that that's x squared and the 3x's will cancel. So it's just x squared minus 9. So it's from -4 to 0, x, and then x squared minus 9. That does not have an x yet, sorry. And then -7x. And then I'm going to distribute this x. I'm going to have x cubed minus 9x minus 7x. So it's basically the integral from -4 to 0 of x cubed minus 16x dx. And then we can go backwards. 1/4 x to the 4th minus 8x squared from 0 to -4 to 0. And 0 is 0. And so then I'm going to have 0 minus, and in parentheses, -4 to the 4th, I believe is, wait, not 64. But we are going to divide it by 4, so I think we're going to end up with 64 when all said and done. And then -4 squared is 16. So 8 times 16. I think that's 128.
Yeah.
Sweet. Distribute the negative, so -64 plus 128. Or 128 minus 64. Wait, isn't that just 64?
Yeah.
Yep.
Yeah.
So it's 128.
That's true, we still got to double it. So double. So 128 is the final answer. Which that doesn't look right. I like realize if you're looking at it, you're like, how the heck is that like that big? But you have to remember that that's like not drawn to scale because it looks like that 428 point is at 4.4, but it's actually at 428.
So I did like the left half of that one and got -128, probably because I flipped my bounds when I was plugging things in, and I was like, oh no, it's negative. That means I did something wrong. So I went back and chopped the half into like 3 sections with like the curve from like -4 to -3, and then the line from -3 to 0, and the curve from -3 to 0, and did all of that and added it up. And I got the same answer, but it took like 4 times as long.
Yeah, that's fair. Oh my goodness. Hey, that's nice that you got the same answer.
Except in retrospect, I think some of that, like, maybe shouldn't have worked. Because I think I don't know.
Well, as long as you keep the right thing on top, technically you can chop the bounds wherever you want, I think.
Found a Cadbury cream egg.
Hey. Wish you could share, but that's okay.
Yeah.
Oh, thanks, Eli. I think I'm feeling good on that page. So I'm circling things as we go. So we've gone over 2, 3, 5, and 6. So I'll post 1, 4, and 7 when we're done. So moving on to the last page, I did number 11 in the notes.
Mm-hmm.
So let's either do we can do like 2 of the 3, but not maybe all 3. So pick 1 or 2 from the
9 and
last.
10.
Well, those are so similar to each other, though. Well, let's do one of them, and then we'll see how you guys feel about the other one. How do you guys feel about that?
Okay.
Yeah, and I do realize these are gross because they only give you one of the meeting points. So that's totally for real here. What do you guys want to start with, 9 or 10? You guys have a preference?
10?
10, and then we can go back to 9 if need be. So 10 is nice because they at least give you the fact that this is the point. 6. Now remember, that is not like drawn to scale. But we need to find these 2 points, essentially, is what's gross. And this is, again, where it would be super nice to be able to use our graphing calculator, but it's just really good algebra. So I'm going to set 3x minus 5 equal to the x cubed minus 5x squared minus 5x plus 7. And the reason that they actually gave you 1 point out of the 3 is because it's been so long since we've done this this type of thing. We actually wouldn't be able to solve this thing, this cubic right here, like, because we can't factor it like that. Like, there's nothing you can pull out. So this is this is crazy. But this is back in the day. Do you guys remember? Since they told us that 613 is a solution, is it okay with everybody that x minus 6 is actually a factor of this thing, because we know that x equals 6 is one of the answers? Does that make sense?
Okay.
So without them actually telling us that, though, we would not be able to do this algebraically because there's no good way to factor a cubic. But as soon as we do that, you can actually do short or long division, which I'm going to tell you guys, if you have to do one of these on the test, I will give you your calculator so you can just help yourself by finding the points in your calculator. But since we're taking homework questions, I say we do it just to, make sure we refresh ourselves. I would say, is everybody okay if I refresh you on shortcut division so that we don't have to do long division?
Yeah, I
Yeah.
forgot that was a thing, and I did it the long way.
Yeah, I mean, long division also works. I just like long division worse. Short division is where you put the 6 on the outside because it's whatever this is solved. And then you put all the numbers that come in front of the x is, so like the coefficients, you put all of these up here. And then my Alg 2 students would have a heyday right now, and you guys did too, and you're in Alg 2 because it's just like multiplication and addition. You just bring the 1 down. 1 times 6 is 6, and then you add these. -5 plus 6 is 1. 6 times 1 is 6. Then you add these, that's -2. 6 times -2 is -12, and those are 0. And it should be 0, or else they gave us a false solution. Because now what happens is this is actually x squared, and this is actually something that we can factor now.
Yeah.
Would I have expected you to know all of that in your head still? No. So if you had to use a calculator to find those points, that's okay. But so what do we get here? X plus 2, x minus 1. Is that okay for everybody?
Yeah.
X equals 2, x equals 1. That means that this point is -2 comma something. And this point is 1 comma something. And we could plug them back in because it's really easy to plug them into the line 3x minus 5. But again, we wouldn't have to. Right, so this is like 1, -2 because I just plugged that back in. But we really just need the x values, right? We just really need the 6, the 1, and the -2. And now I have to go to the next page to do this, but is everybody good with the fact that we're going to have to do the integral from -2 to 1, and we're going to have to do the cubic on top and the line on the bottom?
Yeah.
And good. And then the next one we're going to have to do from 1 to 6, but we're going to have to do the
Line on top.
yeah. Sweet. So I'm going to go to the next page because I got the homework right here, so I can write that out for us. So it's the integral from -2 to 1 of cubic on top, line on the bottom. And then we're going to have to go from 1 to 6 of the line on top, cubic on the bottom. And then you guys might recognize this, but when you go to like distribute the negatives and stuff, you're going to get the exact same like thing that you're going backwards from. You're going to get the exact same thing to integrate, except for with different symbols. Right, so when I distribute this negative and get -3x plus 5, when I go to combine my like terms, I'm going to have x cubed minus 5x squared minus 8x, because I'm combining these two, and then plus 12, right, which is actually that thing that we factored as well. And then over here, when I do the same thing, instead of getting this, I'm going to have a -x cubed, a positive 5x squared, and then a positive 8x, and then a minus 12. Right, so technically you get the same polynomial, just everything has different signs. Because when you subtract one from the other, it's the same thing, but just different symbols. And now we go backwards. 1/4 x to the 4th minus, oh, this one's going to be gross. And we don't even have a 0. Oh, that's awful. So sorry in advance on this one. That's just nasty. And the 6 is going to be really nasty.
I had like basically half a page of work on this problem.
I'm so sorry. This is a good one to do, though, everybody. Well, we will save our work because we will be able to figure out what we get when we plug 1 in. And it'll be very similar for the other one. Okay, everybody ready to check my mental math? So we're going to have 1/4 minus 5/3 minus 4 plus 12. That's what we get when we plug 1 in, because that's at least almost as good as 0, not quite. And then when we plug -2 in, I'm going to subtract out. All right, -2 to the 4th is 16, divided by 4 is 4. -2 to the 3rd is -8, but times -5/3 is plus 40/3. -2 squared is positive 4, times -4 is -16, and then -24. I'm not quite sure what I want to do, but I think I'm just going to distribute this and combine some like terms here. It's because the 1/4 is just chilling, but the -5/3 will combine with the 40/3 over there. -4 plus 12, why not? I can put those together. That's 8. Then I'm going to have -4 minus 40/3 plus 16 plus 24. That's probably good because we probably should get a positive number. So -40/3 and -5/3 is -45/3, which is actually just,
15.
yeah, -15. And then these two together is plus 4. And these two together is plus 40. And we still have a 4th. 1/4. But -15 plus 40 is 25. So 29 and a 4th.
Yep.
Woo! All right. I'm going to put what we get when we plug 1 in first, because I don't want to do 6 yet. Ew. So -1/4 plus 5/3 plus 4 minus 12. Because because it should be the opposite of what was over there. Okay. Great.
6 to the 4th is 1,296, if that helps.
Yeah, we can do that. Why not? That actually is divisible by 4, though, right?
Yeah.
So if we
I
cut
believe
that,
you get 360.
I was
Wait,
gonna
no,
say-
324.
yeah, I was going to say, I don't think it'll be even, but that makes sense to me because half of that is like 648, and then half of that would be 324. Yeah. So let's do that. So negative 324. And then, dang, plus 5/3, 6 cubed. Isn't 6 cubed 216?
I don't know, but 6 cubed times 5 is 1,080,
1080, yep.
which divided by 3 is 360.
Oh, that's divisible by 3. Oh, yeah. Uh-huh. And then 36 times 4.
Ugh.
144.
Yep. Plus 144. I'm running out of room. Minus 6 times 12 would be minus 72, right? Hey, all those are whole numbers, though. I'm feeling very encouraged right now, friends. So negative 324 plus 360 is a positive 36, I believe. 144 minus 72.
72.
Yeah, that's half of it. That's double. And then I'm going to distribute this negative to these. So plus 1/4 minus 5/3 minus 4 plus 12. We're getting somewhere. 78. This is 108. These two together are. This is 8. And then plus 1/4 minus 5/3, of course. You know what? I'm going to get a common denominator here. So I'm going to have 116. And then 3/12 minus 20/12 is negative 17/12. That's 115 minus 5/12. I'm running out of room. There we go. Which is 114 and 7/12. Does that look right?
Yep.
Add those together and you'd have your final answer. Wow, that's nasty. And so I make this a 3/12 is 114, or 1/4 is 3/12. So 10/12, which is 5/6. The final answer, I don't even have anywhere to put it. I'm just going to put it in yellow in the middle of the screen. So 5/6, and then whatever 114 plus 29 is. 143.
Yeah.
Oh,
Woo!
all right.
Persevering. What we could do if you guys want is for number 9, we could just set up the integrals and then you guys can mint them to double check yourself.
The only issue, like, the only problem is just trying to find the coordinates. I think that's what messes me up.
Yeah, we could find the coordinates on number 9 and then call it good.
Yeah.
And then I'll post the answers to 1, 4, 7, 8, and 9 on the website under this thing when it loads.
Are we gonna have homework for today?
It is due Monday, so you got a while. So this was kind of the big one for this week, as far as like getting done with it early. This thing is really big. And what do they tell us? They tell us that this one is what, 1, -2, I think is what they tell us. Yeah.
Yeah.
Sweet. So we'll just find where they meet and then we'll leave it up to you guys to end this thing. So to find where they meet, we got to do that division thing again. So now maybe that you guys have a refresher, you can help me out. So I'm going to set the 2 equations equal to each other. Move everything to the same side. Oh, actually, this is even better. Never mind, this is great. Instead of doing shortcut division, this one, do you guys remember that whole like grouping thing?
Yeah.
If you don't remember, we'll refresh you. This is awesome. This is where you take out what these have in common, which is an x squared. And if you took an x squared out of just those two, what would you have left?
X minus 1.
Nice. And then what do the next two things have in common?
3.
A 9.
A 9, yeah, be even bigger than 3, perfect. And I'm gonna take out a -9 because technically I need to do that because then I get x minus 1 in the parentheses, and the parentheses need to match. If we just took out a 9, we'd have x negative x plus 1, which would be gross. Now what you do is you actually just take this guy out of both of these terms, right? And then you're left with x squared minus 9. And then you set both those equal to 0 and solve them. And if you solve the first one, you get x equals 1, which we already have. But if you solve this one, what do you get?
Plus or minus
3. Plus minus 3.
So that means this is the point -3 something, and this is the point 3 something. So for you guys to finish this one then, you'll have to do the integral from -3 to 1 with the cubic on top, right, minus the line. And then you'll have to do the integral from 1 to 3 of the line on top minus the cubic. And if you wanted to mint those to double check yourselves, you could.
And we just plug the -3 and 3 back into one of the equations to get the y.
Yes, and actually you don't even need the y though. Well, I guess it does say for part A it wants that, doesn't it? Yeah, so if you want to plug it back in, and definitely if you're choosing one, plug it back into y equals 2x minus 4, right? That's easier than plug it in, because you could plug it into either one. So what is that, 6 minus 2? -10, I think.
Yeah.
Sweet. Yeah, I'm feeling good about that. So I know there's a bunch of chances for mental math errors, but are you guys feeling pretty good about the concept?
Yeah.
Yeah.
Yep.
Sweet, because that's going to be